Okay, after we learned the ellipse and hyperbola, today we're going to learn something called a parabola, the last one. Okay. Okay. Do you remember for the conics that um, looks like this? And I said you have a knife, you cut it, and then after you take a cut and then you look at the intersection surface, and then what do you have? If you cut like very straight, like flat, you get a circle. If you cut with a little angle, then you get an ellipse. And if you cut like that, okay, so you're going to end up with this too. So you know that's going to be your hyperbola. However, if you cut like uh, if you cut the angle with, I don't know, it was like this, you cut like that. So you're going to only cut half of that, and you get the intersection face looks like this. This is a hyperbola. Okay, actually there's one hyperbola that we learned, quadratic, right? It's a quadratic curve. All right, now what's the definition of that is there's a point, there's a line. Okay, this point we call this is a focus, and this line we call that a directrix. Okay, and then I ask you to give me the point so that the distance between the point and the focus is the same as the distance between the point and the line, the directrix. So here, this point is good, right? And maybe here's good because this distance and this distance stays the same, all right? And if you cut that, then this and this are the same, right? All right, now you keep going. So maybe here is good because see this distance and this distance is the same, right? Once you give me all the points, guess what? You get the parabola. Right, so that's the definition of this. And we know this is the focus, and here's the directrix, and this point, again, we call that a vertex, okay, because there's only one focus and one vertex in this case. Okay, and this distance, this distance is going to be called P and P, P, P. All right. Now, if I ask you, here's a point, here's a directrix, and here's that. What happened when this? How long is this? Remember, here's a P, here is P. So for this point, the distance from this point to this directrix, that's 2P. Therefore, here is also 2P. It's interesting, isn't it? Okay. So if we take this vertex, we will put this vertex at my origin, then I will have something like that, huh? Okay, so that is this. Is uh, x squared equals 4py. Here's p. Okay, and this, and also if you have something looks like this, that is y squared equals 4px. And in this case, my p is positive, and this one, p is positive. Okay, so we have a 4 different type of graph. Let me show you. Number one, if I have x equals 4py, and my p is positive, I'm going to have something look like this. If my p is less than 0, I'm going to have something look like this. All right? And if I have a y squared equals 4px, and my p positive, I'm going to have this open right. And if my p is negative, it's going to look like this. All right, now, so for everything I showed you, it just looked like this. I haven't tell you anything about the vertex yet. And usually we put the vertex as hk. Therefore, this formula becomes x minus h squared equals 4p y minus k. Okay, and that would p positive, you're gonna open up, p negative, open down, and this one is y minus k squared equals 4p x minus h. Okay, center, not center, no center, vertex and hk, and p positive, open right, p negative, open left. So we have open up, down, left, and right for different situations. Okay, so that's an interesting thing, right? Parabola. Okay, now I ask you to find the focus. I didn't say foci because there's only one. Okay, directrix, which means the equation of this, of y squared equals 8x. Y squared, because y could be positive, negative, so it's easy to tell. It should be left or right, that type. And here is positive, so it's going to be like that. That's one we know. All right, so the y minus k squared equals 4p x minus h. And in my case, hk is just 0, 0, and that is my vertex, right? Okay, and then if you compare this with that, not only we know that hk is 0, 0, we also know 4p equals 8, right? You compare this with that, 4p equals 8. What is p then? P is 2. Okay, now do you remember what is p? P is the distance between vertex and focus, and the same as distance between vertex and direct. P is 2. We have a 0, 0, we have P2. So we have this 0, 0, this is x, this is y. And here is the vertex. And then we have this shape, left and open to the right. So we go right by 2, again my focus. I go left by 2, again my directrix. Right? So I should have a curve look like this. Okay, I got a very good question from my class. Like, how do we know, how do you know the opening is at a wide or narrow? All right, now you think about that. Here's a 4, right? From -2 to +2 is 4. So do you remember that if you have x equals 2 somewhere, and then the distance between this point to this line is 4, and should be the same distance from this to here. Is that right? By the definition. So it should be 2p. Okay, so you should go up and down by 2p. 2p. P is 2, so it should go up down by 4. That can tell you how wide your opening should be. Looks good? It's much easier, isn't it? And then where's your focus? Of course, it's here. That's a 2, 0. And your directrix, which is a line, the equation of that, which is x equals -2. That's it. So it's very easy, isn't it? All right, now let's work on another one, number 2. I ask you to find the standard form of the equation of a parabola with, pay attention to this, okay, with focus 0, 8, and directrix y equals -8. Think about that. Where is it? 0, 0, 8, which is here, right? So that's your focus. And directrix is y equals -8, so it's here. That's y equals -8. That's my x, that's my y. So what do you know? You know the midpoint of from here to this line, the middle, which is 0, 0. So we know hk, which is 0, 0. And my graph should look like this. So which is the x minus h squared equals 4p y minus k, like that. And hk is 0, so x squared equals 4py. And what is p? P is the distance between the vertex to focus, which is 8. So p, I know it's 8. Therefore, x squared equals 32y. That is my answer. Or you can, this is the standard form, but in the old time that we will learn the quadratic curve, actually it's y equals x squared over 32. It's the same thing. If you graph that, and it's the same as this one. Okay, so that's the standard form of this. It's not bad, right? I think it's very easy. Among those three, hyperbola, I think, is the most complicated one. And then ellipse is not bad. And this parabola, I think, is the easiest one because it has only one focus and only one vertex. All right, now, number 3, I ask you to find vertex, focus, and directrix of this. X minus 2 squared equals 4, y plus 1. Because it has x squared, but y has only linear term. So that's the parabola, only one square and the other one linear. And this x squared, so this part can be positive, negative, therefore it's a left and right, and therefore we have something look like either this or this. But since this guy is positive, so we have this one, not that one. We have this open up type. Okay, so the standard form is this: x minus h squared equals 4p y minus k. All right, now what is h? Is 2. What is k? Is -1. So your vertex is hk. Therefore, it's 2, -1. You get your vertex. Okay? And what else you know? You know p. Because 4p, if you compare this with the standard form or the formula, that 4 equals 4p. So p is 1. All right, now let's see. When we graph, that's the x. This is y. All right. Now we have 1, 2, 1, 2, -1. So 2, -1. That is my vertex. I know I need to open up like that. I need to open up with the p. P is 1, so I should go up by 1 to get this. This is the focus. Okay, so what I know the vertex is 2, -1. And what about my focus? My focus, because I just need to go up by 1, so that's 2, 0. And what my directrix? I should go down by 1 and then draw the line, right? So that is y equals -2. All right? Now when I graph, so I go up by 1, and I have this focus, and I go to the left and right by 2p. So which means here and here. So I can graph. Looks good. I can graph it. I can find the vertex, I can find the focus, I can find the equation of this directrix. All right, now as long as you know this, I think the four, where was that four shape? Then you can graph it, and you can find the vertex, you can find the focus, and you can find the equation of this directrix. Okay, so this is very easy, and now you can tell how, if I give you an equation, an conic section equation, how can you tell whether it's a ellipse or hyperbola or parabola? Okay, first of all, you look whether you have x squared and a y squared. If you have only x squared but no y squared, just y, or you have only y squared but no x squared, you just have x, then that is a parabola. And then if you have an x squared and a y squared, but they have a different coefficient, they have the same sign, then that is a ellipse. If x squared and y squared both have a square, but they have an opposite sign of a coefficient, then that's an hyperbola. Okay, so I think that's all, and I always believe this parabola will be the easiest one. Okay.